For those of you who are new, thank you for joining us. This is part of a series of free monthly programs we offer at Whidbey Audubon Society, and we couldn't do it without the support of our members. It's really important. Before we get started with Montserrat, isn't that how you pronounce it? Okay, Montserrat. Before her presentation, we'd like to talk a little bit about our organization and the work we've been doing and how you might be able to get involved with it. While many of you are frequent flyers to our programs, you might not know about other work we're involved in. And I want to know if you'd show me your hands and everything, or write a reaction on there that you saw the South Whidbey record this week, because there was an article about the commissioners meeting, and it was really neat because they said the hearing room was packed, and we heard public comment from 17 individuals across a gamut of issues, including Deer Lagoon Preserve. And it said Public Works brought a discussion on the Deer Lagoon Preserve. Attached to the agenda, there's a draft management plan for Deer Lagoon Preserve, which was written by Carlos Anderson. And I don't know if Carlos is with us tonight, but Carlos needs a big hand because we really appreciate his work. And there were other people there. I see some people reacting to this. Thank you very much. And let's see. They had comments from Govinda on there, and also from Linda Griesbach, and I can't remember who the third person was, but we really appreciate all of this work that's been done on Deer Lagoon. And there's going to be a lot more of it, and there's some comments that could be used from you to the commissioners. And let's see. Next on the agenda, let's see. Ellen Nelson, would you like to talk about Salish Sea Guillemot Network?
Well, I would. I'd like to talk about pigeon guillemots in general, and exciting spring news coming up. And some recent sightings of pigeon guillemots kind of remind us that preparation for the 2026 breeding survey starts in mid-March. And a big part of that preparation is recruiting volunteers and then assigning them to the 23 colonies on our shorelines. So if you're not one of the surveyors returning for the new season, it's a great time to consider spending time on the beach, a jetty, a wharf, surveying these lively birds. So now's the time to sign up as a volunteer. You can go to pigeonguillemot.org to the volunteer tab, and there's an online form you can fill out and submit for that. So it's time. The second thing I'm excited about is the upcoming publication in late March of Maria Madruth's latest book, The Bird with Flaming Feet. It kind of bridges the gap between a field guide and a memoir. And she really asks us to slow down, look closely, and reconnect with wild creatures. She's also the author of Rare Bird, Pursuing the Mystery of the Marbled Murrelet, and A Sideways Look at Clouds. She describes herself as a Guillemot groupie, and she's also a community scientist. And she will be speaking at our May meeting. So watch for alerts about that.
Okay. All right. Thank you, Ellen, for your sharing with us. We appreciate it very much. We appreciate the work you're doing with the Salish Sea Network. And let's see. Govinda, you would like to talk about what happened with the Whidbey Audubon Society Christmas bird count. Yep. And we're glad to hear from you.
Yeah, and I'd also like to add with Maria, she's also a Guillemot surveyor down in the South Sound and has been for, gosh, at least, I don't know, over 5 years by now, maybe 10, I'm not sure. The year is just...
It's 13. It's 13 years.
13, oh my gosh. Yeah. So, yeah, like you had mentioned earlier, Patty, that Carlos Anderson, he had an urgent call, and it was in the February shorelines to comment on the Island County Comprehensive Plan regarding Deer Lagoon. I went up to Coopville last week and presented a spreadsheet that I'd compiled from CBC data of just Deer Lagoon from 2011 to 2026. So last Christmas bird count was our 15th year. That's a really good chunk of data to empirically show the high concentration of wintering birds at Deer Lagoon and hopefully to elevate the space to a preserve of birding priority. And I will say that with the South Whidbey Christmas bird count, often our most abundant species that we survey are from Deer Lagoon. And that was certainly the case with this last Christmas bird count. And I have some totals here. Our most abundant species counted at Deer Lagoon, thank you, Carlos and team, was the Dunlin at 3,777. Some other highlights are second most abundant species was the surf scoter at 889. And the third runner-up was the American widgeon at 800 individuals. Unusual species that we saw and surveyed were osprey and barn swallows. Well, not unusual, but they are when you see them in January. And we also surveyed one western scrub jay that was at Lone Lake, and that's really a first for the CBC circle. Even though we've had sightings of them in Clinton in the past, but we've never gotten them during a Christmas bird count. And as for the number of species of diversity, we tend to hover around 109, and that was certainly the case that we got this last year. And then just to finally, this is the part where I just want to emphasize that there is value in these long-term data can have, and whether it's the Christmas bird count or the Pigeon Guillemot surveys, because you never know when you might need that data. So back to you.
Okay, thanks, Govinda. Whidbey Audubon is very involved in community science and monitoring, which is a very important part of understanding ecosystem health in Puget Sound. And another of these that we have going on is the Great Backyard Bird Count, starting tomorrow. And I hope that some of you are aware of it and are planning on doing it. And it runs until February 16th. We'd like a show of hands of how many Whidbey Islanders are participating in this program. And I'm going to allow Joaquin to have a chance to count you. So go ahead and react with a hand, and under react, you've got that. There we go. Okay. Come on, there must be more. Okay, good. I see hands going up. Okay. Madrone, did you have a question? Or you just had your hand up? Okay. All right. Anybody else? Okie dokie. Very good. We're really happy that you're participating in this. And we'll move on now. And all of our upcoming events can be found on our website that is listed under whidbeyaudubon.org events list. And Joaquin is putting that into the chat so that you will see that. And Joaquin, I don't know if we're recording this, but you might want to record this. Okay, we are recording it. Thank you. We also have some field trips soon, and I don't think David Parent is here to talk about it. He has several things planned. On February 28th from noon to 2 p.m., there will be a small sit at Flintstone Park in Oak Harbor. And those small sits are really kind of nice to do. Let's see, there are a few places left on the pelagic bird trip, the Westport trip, which will occur on June 7th and it costs $220. But if we don't fill these spots soon, we're going to lose them. So be sure and sign up if you want to go. I went last year, and it was the most incredible experience I've ever had. It was just really wonderful. The Winter Birds of Samish Flats and Ver Island field trip is already full and all, but you could still join and be on the waiting list, and we will let you know if there is one of those that you can get involved in. Our next general meeting will be Tufted Puffin in a Dynamic Seascape by Dr. Scott Pearson, and it will be on March 12th, both on Zoom and in person at the Unitarian Universalist Congregational Church in Freeland. Okay, Whidbey Island has been an important part of the community for 40 years. How many of you knew that? How many of you knew that we've been important doing this? I see a few hands. Almost all the work we have done depends on our membership and our member donations and the volunteer work that you do. If you'd like to support us with a donation, please get on the website and donate. And it's on the site, and you can find it very easily. Joaquin has been very good about updating the website, so you should be able to find it. Let us know if you have trouble with it. We'll make sure you can get it. Instead, you would like to actually support us by volunteering, we have many opportunities for that as well. Some are on an event-by-event basis, but some are great for those who want to get more involved. Linda Griesbach, our board vice president, would like to speak for a few minutes about one of these opportunities that's coming up and our upcoming board elections. So, Linda.
Well, thank you, Patty. Yes, I'm Linda Griesbach, current vice president of the board, and I'm taking this time to officially announce that nominations for the positions of president and vice president of Whidbey Audubon Society are now open. The election for these two positions will occur at the May 14th membership meeting. And pursuant to our bylaws, nominations may be made from now until the close of our March membership meeting on March 12. The term for both of these positions is 2 years, and any member in good standing is eligible to serve in either role. We do need candidates for both the president and vice president positions since they're both open. And we have actually not had anybody in the president's role for almost 2 years. It's really important that we fill that position. And we're very fortunate to have a great board of directors, as well as an enthusiastic, energetic, and very capable executive director who all pitch in to keep our organization vital and viable, and it helps keep the workload from becoming burdensome. So if you're interested in running for either position or want more information, please reach out to me. I'm happy to chat about it with you. I can be emailed at vp@whidbeyaudubonsociety.org, or you can just go to our website and under Contact Us, and you can reach out either by email or by leaving a voice message on our phone number. And I will get your message, and I will be happy to get back to you so that we can discuss this further. But thank you for your consideration.
Thank you, Linda. To stay up to date on all of our activities and volunteer opportunities, we produce a monthly newsletter, Shorelines, and event blasts, which are now available for free to anyone who wants to subscribe. If you visit our website, the subscription link is all the way at the bottom of the home page. Joaquin will also be sending a link to the subscription page in the chat. Finally, to Shorelines authors, and we have come up with these ideas and suggestions. So don't forget that Shorelines articles are due next Monday. That's February 16th. And we are also looking for a Shorelines editor for this next year. This is a very important position, so we do need to take care of it. So let us know if you can help. And now, unless somebody has something else that they want to say, does anybody have anything else? Okay. Um, this is a real privilege for me to introduce Monsa, which is, her name is Montserrat Alvarado. She's a biologist from Costa Rica. And incidentally, Joaquin is in Costa Rica right now. So he's able to host the program from there. She specializes in ornithology and vocal communication in birds. She is currently completing a master's degree with a focus on bioacoustics and animal behavior. She studies how birds use songs and duets to communicate with mates and neighbors using the white-eared ground-sparrow, which is Melozone leucotis, I guess is how it's pronounced, as a model species in tropical environments. Her research combines fieldwork and bioacoustics to explore how listening closely to birds can reveal information about behavior, relationships, and territory. Monsa works extensively with field recordings and acoustic analysis and enjoys sharing her research with birdwatchers and nature enthusiasts, connecting scientific research and everyday observation of birds. This talk introduces the fascinating world of birding duets, using tropical species and sound examples to explore when duets occur, who participates, and the different forms they can take. Please welcome Montserrat Alvarado.
Hello, thank you, thank you. Yeah, you can just call me Monse. I know my name is difficult, so Monse is fine. Yeah, so hello, thank you for having me. Um, so first of all, like a few notes. English is not my first language. I was born and raised in Costa Rica, so I speak Spanish. So if at some point I say something that doesn't make a whole lot of sense, or I use a wrong word, and it leaves you with a question, just write it in the chat, and one of us, either me or Keen or Patty's gonna see it, and I'm gonna answer it or change my the words that I use or something. And the next one, if you hear me saying next throughout the presentation, is because I'm having a bit of trouble with my internet. So Joaquin is sharing my presentation and I'm telling him when to pass to the next slide and so on. So yeah, that's gonna be the big. I don't know if we can start sharing so that I can make like the introduction.
Sorry, can you already see my screen here? I already have it open.
Wait, because okay, I can, yes.
Okay, great.
Great, thank you, thank you. Okay, so yeah, my presentation is about birdwits. I'm going to focus on tropical species because, well, I'm going to explain why to you in a little bit, but it's also like the Costa Rica is in a tropical place, and we use a lot of examples from other tropical places, right? Because the behavior is kind of similar. So like this kind of my area of expertise to some point. And yeah, I hope you enjoy it. I hope I can show you or teach you a little bit about this fascinating world of bird communication. Yeah, I don't know if, yeah, I guess we're ready to start. So next. Okay, so first of all, a little bit about me. I started working with birds in 2020. I began by collaborating in the bioacoustics collection of the Zoology Museum of the University of Costa Rica, which is where I studied and I'm currently studying. Here I can show you a picture of one of my classes. I also did a bit of classes. And I teach about birds. So this was me working at the museum. Next. So another fun thing to share is that this last year I published my first article, It's about the status of the bioacoustics collection of the museum. And I published it in a oh, okay. Well, I published it with my tutor. He's Luis Sandoval. If any of you are interested in looking at the article, I can share it. Maybe I can do it after the presentation. I can give you a link. We basically talk about all the species that we have in the collection. It's a collection that includes birds, mammals, frogs. We even have a moth. It's the first recorded sound of a moth in Costa Rica, so that's pretty awesome. Next. Okay, then in 2024, I participated in a banding workshop at the Organization for Tropical Studies. Here you can see me banding my first bird ever. It was a red-capped mannequin. I'm very proud of that photo, so I had to include it. Next. Okay, and I am currently working on my thesis. I am working on my master's thesis. I'm working at the Laboratory of Urban Ecology and Animal Communication. Can you click it? Yes. Thank you. Yeah, this is my laboratory. I'm working with the White-eared Ground-Sparrow, which is a sparrow that can be found from southern Honduras to Costa Rica. I focus on duets and male solo songs. My objectives, are to identify characteristics about the male contribution to duets and to see if there is a tendency for males to sing certain types of solo songs when their mates are removed from their territory. I do this by recording and using recordings from 2011 until 2023. So it's a lot of data, which is really cool because it doesn't happen that often in science. And to get us into duets, my thesis is what first got me interested in duets. I found out that it is a much more interesting and complex world than I could have ever imagined, honestly. So yeah, let's begin. Next. Okay, so here, first of all, before we get into duets, everything relating about duets, we first need to take a look at how sounds are used in this field of bioacoustics. Contrary to what logic would tell, we don't actually work on sounds by listening to them. We actually just see the sounds because humans are a very visual species, so it's way easier to see sound rather than listen to it. So how do we work with sound, right? We use spectrograms. So a spectrogram is a visual representation of a signal. In this case, it is the visual representation of a sound. So it is, can you click please? It's read from left to right. Okay, here we are listening to a song of a rufous-breasted wren. Okay, pay attention to how the image of the sound is and when the pitch goes up and down in the sound. Okay, so yeah, I think there are a few animations. And one more. Yeah, there it is. Thank you. So as we saw, as we saw, the spectrograms are read from left to right. The vertical axis commonly represents frequency. Frequency equals the pitch. So a higher pitch means a higher frequency, and lower pitch means lower frequency. So that's why I told you to pay attention to how the sound looks and how it sounds. And the horizontal axis represents time. So time helps us to see how long a sound lasts. Okay, next. So this material from this slide is from a very useful article from the Audubon magazine. I found it specializes on the usefulness of spectrograms for birding. Next to the number of the slide, you can see there is a QR code to the article. It has an explanation on spectrograms and some information about apps you can use on your phone to make spectrograms while birding. It's very good. I really recommend it. So the writer, Nathan Pipelo, said it best. The spectrogram is very useful to use your eyes to focus your ear on the finer details in sound. So in this recording, we can listen to the song of a black-capped chickadee. Can you play, please? Yeah, I'm sorry. That was a bit loud. So as we listen to it, it appears to be the song, or could be a song made up by two notes or two sounds, one in higher pitch and then a little bit lower. But if we add the spectrogram and analyze the image, you can click outside. Thank you. And then we play the sound again. We can now listen with even more detail. Okay, so it seems now that we have the spectrogram, but the sound is made up by almost kind of three sounds. The second note is divided or it has a little pause in the middle, which is not that obvious when you just listen to the song, but once you see it, you can actually kind of listen to this pause. So to me, it almost feels like listening in HD. So just a quick note, what did I mean by notes? Because we can now see the sound, it is way easier to understand how the sound is made up. To simplify it, we can see two objects on this spectrogram, and each of these is a note. The two notes make up the song, which is the whole of the image. So one is, like I said, a little bit higher in frequency, and then the second one is a little bit longer and lower in frequency. So each of these is a note. Next. So now to the fun part, right? What are duets? So first, to know exactly what duets are, can you click please? We have to establish the different types of vocalizations that are classified as songs. So there are solo songs, which is when a bird sings alone, such as the last example of the black-capped chickadee we just listened to. Then there is the dawn chorus. The dawn chorus is a daily period of high singing activity, shown by many or most passerine and some non-passerine species during the breeding season. Here in the tropics, we have it almost every day of every year, but that's because of the differences, right, in behavior. During this period, many species end up overlapping their songs, so that's what makes up the dawn chorus. And lastly, duets are also in this category of songs. Can you next, please? Okay, so a duet, thank you, is when two individuals of the same species coordinate their song. So this coordination can be in time, frequency, or both. Next. So this next one may be one of the most famous examples of duets. So here we're going to see a duet and a dance of two males of long-tailed manakin. can play it, I hope. Okay, so this dance and this duet is used to attract females. Who we saw on the left, it was the green bird that was at the beginning. And then she flew away. She wasn't interested. So the two males did the duet and their dance. Next. So I'm going to use this kind of methodology for the next slide. So who sings and why do they sing? So first of all, who sings during this duet? So in this case, or in the case of the long-tailed mannequin, the duets are performed when two males sing together. Now, this is a very particular case among duetting birds. In most cases, duets are performed by a pair of mated birds, so a female and a male. Right? Next. So in this case of the long-tailed mannequin with two males, we already know that two males are the ones who sing during the duet. So let's first of all practice a bit of understanding spectrograms. Just as a reminder, remember that the vertical axis is frequency and the horizontal axis is time. Now, here is a sound example of the long-tailed mannequin, but it is a different one from the video that we saw. If you can play it. So this is a vocalization which is called Toledo. If you can click again, please. Okay, so frequency, time, and one more time. There, great, thank you. So this vocalization is called Toledo. As you can listen, they say Toledo. And we can see that on the spectrogram. We can see when the pitch changes and when one male begins the duet and the other one joins in. I'm going to see if I can write here. So we can see when the duet begins and when the second male joins in. And we see this here in this other, both are the Toledo vocalizations. So you can see it. Okay. So here in Costa Rica, we actually call them Toledos because it's very common to be walking around and listening to this duet. So in this case, we see that both males are coordinating their song both in time and frequency, meaning there is an overlap between the songs of the first male and the second male. Can you pass to the next slide, please? Okay. So moving on to the second question. Why do they sing these duets? So in this case of the duet called Toledo, the main function of the duet is female attraction. So an alpha male and their beta male partner sing duets to attract a female to their display area, which is a specific branch in a specific place. So that's why there are a lot of videos on YouTube and so of their displays. Once the female gets to their display area, they start performing different displays, such as the one we observed on the video, where one male jumps over the second one, and they do that again and again. Can you click again, please? Okay, yeah, so they work for female attraction. And another. There we go. So it has been observed by scientists that teams of males that better match the frequencies of their songs attract more females to their display area, thus having an increase in the mating success of the alpha male. So as we saw on the spectrogram in the last image, the more overlapped their songs are in frequency, the kind of better they sound to females. So more females will visit their display area. And once they do the display is when the female decides whether she wants to mate with the alpha male or not. But the secret is in the frequency matching that is called. So next, please. Now we are going to see an example of another duet.
Look at sound.
Yeah. So those very beautiful birds are the North Island cockatoo. This is a native species from the North Island in New Zealand, and it is a rare species that has been affected by the introduction of predators to their environment, as is the case in a lot of like birds and other animals that have suffered from the introduction of pets like cats. So the two birds we saw on the video, you can see that they look the same, but it's more than likely that it's a male and a female. When the male and the female of a species look almost identical, like their colorings, it's what is called a monomorphic species. So just as a disclaimer, first of all, the audio that you're going to listen to next is not the same as the sound we see on the spectrogram. It's because in a lot of cases, the spectrograms are published, but not the sound. So I try to look for a sound that was as close to the spectrogram as I could. So yeah, if you can play the clip, please. So this is only a clip of the whole duet that I found. That's because this species is characterized for having one of the longest songs in all bird species. Their songs can last up to 30 seconds, which is a lot. As you could listen, there are long periods of time when no one sings, but it's still considered one sound. Now, as we look at the spectrogram, we can see that the male and the female of the mated pair alternate their contribution to the duet, right? So first we see that the male sings, Then the female sings, she stops, the male sings, there is a long pause, the female sings again, and the male closes up or finishes up the duet, right? Okay, so if you can pass to the next slide, please. Okay, so in this case, who sings and why do they sing? So the duets are performed by a mated pair. So a female and a male. They are mainly used in territorial defense. So this may be like the reason why they sing these duets. According to a study by Mols and Was in 2006, mated pairs respond more strongly in territorial defense when they listen to a playback of a duet, where contributions to the duet were played from two different speakers. So the speakers were at a distance of about 10 meters, and they played different contributions from alternating the sound in each speaker. So it was speaker A, for example, then speaker B, then speaker A, speaker B. That's how they played the duet. So when they did that near the territory of another mated pair, they responded more strongly, both members of the pair, because they took that as the sign of an intrusion by another pair. So they went out to defend their territory, and they responded in duets. So these sort of experiments are called playback experiments because we simulate the presence or intrusion of birds in an environment using recordings. So here they simulated the intrusion of a pair on the territory of another mated pair using speakers and recordings from, I don't know, birds from another, or like a mated pair from another place, or it depends on what their objectives are. Let's playback experiment. Next, please. So here we are looking at a rufous and white wren. This bird can be found from southern Mexico to northern Colombia and Venezuela. So we're going to listen to a duet by this species. I want you to pay close attention to the last part of the recording. In the last part of the recording, we're going to be able to listen to an overlap between the songs of the two birds. So if you can play the sound. Okay. Just again, the sound that we just listened to is not the same that is on the spectrogram, again, for the same reasons. It's kind of difficult to find videos and audio with the spectrogram attached to it. So as we see in the spectrogram, or another duet of the same species, right? We can see that there is an overlap in time. There isn't much of an overlap in frequencies between the song of the male and the female. So the black bar is the male song, and the white bar is going to be the female song. So here we see that the male begins the duet, and then the female starts like about halfway of the male song, but they don't overlap in frequency or pitch, right? The female sings, and as she's in the, what is it, like fourth part, or yeah, the last part of her song, the male begins another song, right? Yeah, next, please. Okay, so who sings in the duets of these species? So the duet is performed by a mated pair, again, a female and a male. And why do they sing? So they appear to be used in communication, between both members of a pair. It could also be a form of mate guarding, meaning it's a way for an individual to protect their mate from being stolen by another. So in this case of this specific species, it seems that it's more of a mate guarding by like it's an intention for the male. So he's protecting her female from being stolen by an outsider male, right? That's what mate guarding is. Next. So to summarize a little bit, who sings and why? So as we saw from the last examples, can you pass to the next one? It depends on the species. Sadly, this is mostly the case in a lot of questions that we have in biology and animal behavior. But luckily, this is what makes it so fun, trying to find the answer to the questions that we have in science, right? Next one. So now more seriously, who sings and why? Most pairs that sing in a duet are mated pairs. Can you click, please? Okay. However, that is not always the case, as we saw in the case of the long-tailed manakins, but most species are duets are performed by a mated pair, right? Can you click, please? So why do they sing? There are multiple reasons, but some of the most common hypotheses for the functions of duets are that they maintain reproductive synchrony between the pair. So this is what is reproductive synchrony. So it means that both the female and the male are fertile at the same time to reproduce. So they sing these duets as a signal to their partner to say, okay, we have to start mating and reproducing, and they synchronize their fertile periods, right? Next one. So another hypothesis is signaling commitment between partners. So they say, yes, I am with you, I'm not leaving you, and we're together in this kind of, right? Next one. Another hypothesis is communication between the pair. This communication can be maintaining contact when they're out of sight of each other, or even identifying each other. So when there is one of the mated pair, I don't know, the female is in their territory and she listens to a bird. So they make a duet to establish, yes, this is me, I am your mate. You don't have to come out and fight, right? Next one. Another hypothesis, as we saw in the case of the Northern Island kokako, is joint territorial defense. So mated pair hold a territory and they defend it together. Next one. And mate guarding, which is the case that I mentioned from the last example. So they're protecting their mate from being stolen by another. Now, these functions may be true or not for different species. Next, please. These hypotheses are not mutually exclusive, and more than one can apply simultaneously, meaning that duets may serve different functions for a species. So they can work for joint territorial defense and communication between the pair, for example, right? It depends on the species, how many of the hypotheses apply. Or it could be another hypothesis, we don't know, right? Okay, next. Okay, so finally, what are some general characteristics about duetting species? There are some general characteristics that can apply. However, we saw that it depends on the species, but in general, duetting is mostly a behavior that is found in the tropics. But there are some species or some temperate species that sing duets. A lot of them are owls, I found out. But they're not I mean, they are studied, but maybe they don't have as complex a behavior as the ones in the tropics because it's a lot more common in the tropics, right? Um, oh, can you click 3 times, please? Okay, yeah, it's better that way. So both in tropical and temperate species, it is common that the pair maintain. I'm sorry if you heard that. There was a motorcycle passing by. Both in tropical and temperate species, it is common that the pair maintain territories year-round. And this also relates to the fact that many duetting species form long-term monogamous pair bonds. So a lot of duetting species will mate and be monogamous for long periods of time. We're talking a year or more years. And they hold, or these two birds hold a specific territory all throughout the year. It doesn't matter if they're not in their in a reproductive time period. They're still going to defend their territory, right? Next. So let's talk a bit about duets and some types of duets in general. Funnily enough, when I first started researching duets, I found a lot of information on polyphonal and antiphonal Gregorian chants. So here are 2 examples of each form of singing. So the first one is antiphonic singing, which we're going to see. I want you to pay attention to how both choruses alternate when they are singing. So if you can play the clip. And next, that was antiphonic singing. And this one we have here is polyphonic singing. So here are only 2 singers, and notice how they both sing at the same time. Now you can play.
Ad divingenza fine usque ad finem fortiter, so aviteque disponens omnia.
Okay. Next. So bringing it back to birds, right? So what would be antiphonic and polyphonic duets? So as we saw in the first video, antiphonic duets would happen when the 2 singers, or in the case of the video, the 2 choruses, alternate their vocalizations without an overlap in time, right? We can see here on this image that this is the case of the buff-breasted wren and the happy wren. So these 2 here. We can see that the female song in red and the male song in blue, they don't overlap in time. So they are so coordinated in their performance of the duet, but sometimes it sounds like just one bird is singing, but actually the female and the male are alternating their songs so well that there are almost no pauses in sound between each song, right? So that would be antiphonic singing, right? So they alternate their songs. And the other hand, or the other case, would be polyphonic duets. So polyphonic duets are made when the singer, or the singers sing their songs and they have an overlap in time. So here we can see in the case of the rufous and white wren, this one here, the same. The red is the female song and the blue would be the male song. See that they have an overlap right about here in time where the male is singing and then the female joins in, right? So they have an overlap in time. But in this specific case, it is not as the one we saw when we talked about the rufous and white wren, here they actually have an overlap in frequency also. As you can see, here are a bit of the notes of the female song, and they overlap with the male. But the most important part in this case is that they have an overlap in time, right? Yeah, next. Okay, so there is a special advantage to working with species that sing antiphonic duets. So since there is no overlap between the songs of the female and the male, it's easier to separate the different contributions, as we can see in the case here of the black-bellied wren. So here we see this one up here is a duet, and it is easy to separate the male and female contributions. So we can see a spectrogram with only the male contribution. And here we see a spectrogram on the right with only the female contribution, right? So we are able to study each contribution separate from one another. Now, in the case of the white-eared ground sparrow, which is the species that I work with, we can see that the contributions from the female and the male look almost identical. And this is a very good spectrogram because in a lot of cases, they don't even look this different between one another, right? But when they sing together and they make a complete duet, as we call it, where the female and the male sing, we can see that there is an overlap in time and frequency, right? So we are not able to separate the contributions of the male from the contributions of the female. So this makes it harder to study a complete duet. Now, I know that in this case of the black-bellied wren, we didn't have an audio, but we can listen to the audio of the white-eared ground sparrow. So we're going to listen to two types of duets or two types of songs. You can play it. Okay, so I hope you were able to listen. It was a kind of high-pitched sound. The song is very high-pitched. So they sound almost the same. It is very difficult to know in the field whether it was only a male singing his contribution or only a female, or if they were both singing a duet, right? So the first one was a complete duet, which is when the female and the male sing together. And the second one was an incomplete duet, as we call it. So I am not actually sure if it was the female contribution or the male contribution because they sound and look the same in the spectrum. But the interesting thing is that they sound almost identical, both. I don't know if you can play maybe the clip again to see. Yeah, so they sound very similar, right? Next. Okay, so I'm gonna clear all drawings. Let's go. Okay. Now, touching on very lightly on some other subjects that are related to duets. First of all, we know that in most species, a duet is performed by a mated pair, so a female and a male. So this leads us to female song. Most of the species where females have a solo song, they are found in the tropics, right? But more interestingly, what are the functions of female song, right? Can you click, please? So the functions of female song are very similar to some of the functions of male song. One of these is related to mate. So they work for mate attraction, inducing copulation with a mate, and mate retention, right? So they attract a male, they want to copulate with their mate, with their male mate, right? And mate retention. So it's like trying to say to the male, like, okay, stay here with me, leave me, right? And can you click again, please? There are other functions that are also related to defense, such as in male solo songs. So this defense could be a defense of a territory. It could also be a defense of resources like food or nesting sites, and also a type of defense which is mate guarding. We saw. So I think they're kind of self-explanatory, the defense of their territory, right, against other females, or even in some cases against other males. A defense for resources. It is kind of is related to a defense in territory as well as nesting sites. And mate guarding is what we said, right? They are trying to stop other females from stealing their male mate. Yes. So these functions of female song are also mentioned. Can you go back? Are also mentioned when researching about the functions of duet songs, as we saw. I'm sorry, I got distracted by the next slide, but it's okay. So the functions of female song are mentioned when researching the functions of duet songs, as duets may have another complete different function, or it could have duets may have a joint function. So like in joint territorial defense, the duet is the defense of both pairs of the or both individuals of a pair, or perhaps they could have a different function for each individual, right? Because duets can be started by either a female or a male, depends on species. So the joining individual may have another purpose to performing a duet different to their partner, right? But that is a whole nother thing. It depends on the species and the cases and the environment and all of that, right? It's very complex. Yes, next. So that was female song, right? However, there are species like my white-eared ground-sparrow where females do not sing solo songs and they sing only in duets. So in the case of these species, females will sing alone only when males are not responsive in what is called an incomplete duet. So the female sings, the male doesn't respond. That is an incomplete duet. That's why we can see the female contribution to a duet, right? There is the case, as in the case of the rufous and white wren, where female wrens will frequently sing alone. So they actually have a female solo song that is theirs. Next. Oh, wait, I forgot to mention on the last one that even though in rufous and white wrens, for example, females do have a solo song, it doesn't happen as frequently as the male solo song. So who sings the most is still the male, but females can sing alone without, having their partner join in or have a duet started by their partner, right? So that was what I forgot. Thank you. Okay, so a little bit. So what are bioacoustics, right? So According to the Merriam-Webster, it is a branch of science concerned with the production of sound by and its effects on living organisms. So this basically means that it is a study of how sound is produced by animals and how these animals are affected by sound, which can be sounds produced by other animals, sounds in the environment, and even anthropogenic sound, or what we would call anthropogenic noise, right? This last characteristic of studying the effect sound has on animals means that this area includes the study of animal behavior. Next. So when the focus of bioacoustics is on animal behavior, we use recordings and observations. Now, observations can be either done in the field or in a lab to answer questions about the effect of certain sounds on animal behavior. Okay? So the effects of a playback experiment, for example, that we mentioned in the case of the North Island kokako, right? That will be working with animal behavior. Next. So how do we get these recordings that we work with on bioacoustics? So these recordings can either be passive or active recordings. Active recordings are usually shorter recordings with handheld microphones. As we can see here, this here is a mic, and I think in English it is called a parabole to enhance the recording. Okay? These recordings are much more focused on a specific target. These microphones are used as like you point and record, and so it's very localized your recording, right? Or the other case are passive recordings. So passive recordings are made when an autonomous stationary recording, which we see is this box right here, is left on the field and programmed to start and end a series of recordings during longer periods of time. So we can leave a recorder on the field and we tell it or program it to record the dawn chorus from 4 a.m. to 8 a.m., 2 days of the week during a month. So we're going to have a whole bunch of recordings at the end of it. And then we go back and we take the recorder or we change the memory card and we can work with it's a lot of hours of recording because you just leave the recorder out in the field. So this last method are usually used to monitor biodiversity or rare species. They are being more and more used and they are getting more and more smaller. In the bioacoustics collection in the museum, we have old and new recorders, and the old ones are boxes like about, I don't know, inches. So I'm going to have a trouble with that, but maybe they're like about 30 inches. It's a square and they weigh up to 2 kilos. I don't know if maybe you can Google it or I can Google it later. But they're very heavy and very big. But now we have recorders that are smaller than a phone and they almost don't weigh anything. So technology is getting better and better because they're being more and more used, right? So how do we, or not we, I don't, but how do scientists use these recordings to monitor biodiversity? For example, there is a project that is in Mexico where they use these types of recordings to monitor bird migrations from USA or Canada, and they pass through Mexico going to Central America or South America, right? Or in the case of rare species, there is also a project in South America where they are using autonomous recordings to monitor an endangered species. The condor is an endangered species in South America. So they leave the recorder on the field and then they look for vocalizations from the condor, to see how many there are, how frequent they are, if maybe they can find different individuals by the vocalizations that they make. So it's very useful when you cannot precisely go out in the field with a handheld microphone and record your species of interest. Next. There. Okay, so closing up, right? Bird duets show us that song is not always an individual performance, but it may be a shared performance. Across species, duets can serve many roles, and these functions can vary with ecology and social structure, meaning it depends on the species. Bioacoustics allows us to move beyond simply listening, and it gives us tools to visualize, measure, and better understand how birds communicate, right? Maybe even the functions of their vocalizations to communicate. Even so, scientists are still only scratching the surface on this fascinating behavior, and there is still much to discover. By studying duets, we gain an insight not only into bird behavior, but into how cooperation and coordination evolve in the natural world, right? How different species use this coordination and cooperation to achieve a single goal or different goals for each of the individuals. Next. So, thank you very much. I hope everything was understandable and that you enjoyed the presentation and the videos that I had. I know it wasn't many, but it's not very easy to find them. So I hope I was able to explain it to the fullest extent. Yeah.
Oh, good. Some people are reacting and are saying it's not what they expected. Okay, very good. And I do think that we had a really good time listening to you. Are there questions right now? If so, I would be glad to take it. Somebody says it was very interesting. If anyone has any questions, you can also send them to the chat and we'll make sure that they get answered. Good. Linda Griesbach. I always tend to get her last name wrong, but she said it was a very interesting presentation. Anybody have questions? Take yourself off of the mic. Take it off and put it on, and let's listen to you. Anybody? I don't see a hand up. Okay.
I'm curious how long, Montse, you've been studying this particular field.
Yeah, so I have been working with bird recordings for since 2020, is what I started with. However, specifically with bird duets and how they work, since 2023, I believe. It's when I started my master's, yeah, and that's when I got fully interested in the field. Yeah.
Anybody else? Well, I guess I don't have a lot of questions. You were very detailed in giving us the instructions on the way that the frequency works versus the different. Well, I can't even think of the term now. But anyway, it's just whether or not that's going up or coming down or whatever. And you did did show that very well, and it was nice to have the illustrations. So,
Yeah, no, I hope because I'm sorry, it is a very useful tool when birding. Because, well, here in Costa Rica, we have, what is it, almost more than 900 species of birds. And seeing the song it makes it way easier to understand how the song goes, right? And I hope it's going to be a very useful tool to people out there. Yeah.
okay. Everybody take yourselves off of the mute and put your face on the camera and give her a hand.
Yay.
Yay.
Good job.
Thank you very much, Montserrat.
Thank you. Thank
You're
you.
welcome.
Thank you very much.
Oh, I see some.
There's a couple questions in the chat. I
Yeah.
really don't have a voice here, so I'm gonna let somebody else read them.
Well, that's all right. I'll read it for you. One of the questions is there a possibility that in the case of the long-tailed manakins that they are collaborating to amplify their territorial range?
Yeah, so the case of the mannequins, it's very particular because they perform what are called leks. So it is basically an area where a lot of different groups of males will have a performance arena, so to speak, right? So it is not that much of defending their display area, is more of attracting. So one of the hypotheses that I saw in the case of the long-tailed manakins is that when both males synchronize, if you remember the term frequency matching, when both males are able to synchronize in frequency, the song may sound louder or it sounds better. So it would attract more females. They said it was maybe to make the song sound louder, but they weren't completely sure on that hypothesis. However, it is not of it doesn't have a function in territorial defense. It works mostly in female attraction.
So two voices are making it louder.
Yeah, that was like part of the hypothesis. Yeah, but they were not sure, right?
I see.
We don't know how females or how far away they are able to listen. So, but it does sound better. Like when you listen to males that are not frequency matching, it kind of sounds like a mess a little bit. So definitely frequency matching, even if it is coordinated in time, frequency matching is always going to sound better.
That's good. One of our people has said that she would like to read the paper that you wrote, so we want to be sure to have that information on
Yeah.
this. And
Yeah, perhaps I don't know if I can. I'm sorry if I can maybe share later a translated document because the article I just remembered it's in Spanish, or maybe the article is available to download. And I know there are many engines and AI engines that can translate the article. So maybe I can.
oops, you're on mute. Monse, you're on mute.
There we go.
There.
Yeah. And if anyone would like to download the article and translate it, so yeah, it's completely free and available to anyone. Yeah.
Okay.
She just sent via link in the chat.
Right.
Oh yes.
And you were asked, do you study at the Wilson Observatory?
No, I only work here in Costa Rica, right? Yeah. It will be cool, but no.
Well, that was a question. And this person also said she's got a new way to listen to duets now, which is
great.
And that's it. So, okay. Anybody else? Jeffrey, do you have a question?
Yeah, Who would you recommend as reading on this subject apart from yourself and your article?
Well, it kind of depends, because there are different people working with different species, and sometimes they don't always overlap in their investigations. So actually, I can't answer that question, but perhaps I can do a bit of searching and I can send Joaquin or someone
Oh,
an article or a book or something that maybe you can read.
Yeah.
See, here I saw.
Nathan Piplow would be really good, and he has
okay, good.
a lengthy book on it, and he really goes into all of the different parts of both the visual and the listening parts. So he's very, very good at it, and he did write a whole book on it. I think it's a Peterson book. So
Thank you. All right.
anybody else?
I'm going to bed.
Okay. Well, let's give her one more hand and thank you again. And we're so glad that you presented to us. And we know this is one of your first opportunities to do this. So it's great that you did it for us. Thank you very much.
Thank you. It was
Thanks
great.
to Joaquin for getting her. Okay.
Thank you for having me.
Okay. Everybody, good night. Have a good, great birding day starting tomorrow. Okay.
Good night.
Okay,
Good night.
Patty.